Why is memory protection essential for OS stability? Imagine a busy city where every building shares the same street. If one building's plumbing leaks or a fire breaks out, it could damage the entire neighborhood. That's similar to what happens in a computer without memory protection. When you run multiple programs on a computer, each one needs its own space to work without interfering with others. Memory protection makes sure that each program stays in its own lane, preventing one from accidentally or intentionally messing with another's data. This is vital because if a program tries to access memory it isn't supposed to, it can cause errors or even crash the whole system. The operating system manages this by giving each process its own virtual address space. Think of virtual addresses as a map that the operating system and hardware work together to translate into real physical memory locations. The hardware component called the memory management unit helps enforce these rules. It checks every memory request and blocks any that are not authorized. This way, multiple programs can run at the same time without stepping on each other's toes. Different operating systems use different methods to protect memory. Some use segmentation, which divides memory into sections like code, data, and stack, each with its own rules. Others use paging, which breaks memory into small, fixed-size pages that are mapped to physical memory. Both methods help the operating system control who can access what, making the system more secure and stable. In systems like Windows, virtual memory with paging is used to keep processes isolated. Linux and macOS also relying on virtual memory and separate user mode from kernel mode to protect sensitive parts of the system. Older or specialized systems might focus more on segmentation, but the goal remains the same. Keep everything safe and stable. Memory protection also boosts security by stopping unauthorized access to sensitive information. It helps detect malicious or faulty programs before they cause serious harm. Plus, it allows the operating system to allocate and free memory efficiently, making sure resources are used wisely. Without memory protection, a single bug or malicious attack could corrupt data, cause crashes, or even allow hackers to take control. That's why memory protection is a key feature for keeping the operating system running smoothly and securely. It ensures that each program can do its job without risking the entire system's health, making computers reliable and safe for everyone.